Hi, this is Richard C. I'm a math tutor with Wyzant and answering a question from one of the students here. Uh, he's it's an interesting question because this comes up a fair amount in geometry where we have two different shapes that are combined together. These are called compound shapes. In this case, we have a cylinder, which I'm going to draw here. Oops. Of course, I have to be in the drawing tool in order to draw. So I'm going to try again, draw my cylinder. And then the base, the bottom of the cylinder here. And you can see from the question up here, so the bottom part is the bottom part is a cylinder, the top part is a cone. I'm just going to draw the cone now. And there we are. So the nice thing about composite shapes, at first they look kind of confusing, but the good news is all you have to do is take the volume of each shape and add them together. That's all it is. Now, a lot of people don't know the volume of a cone, which turns out to be 1/3 pi r squared h, where h is the height of the cone. So in this example, we would have h here. H would be the height of the cone. And the volume for a cylinder is something that everybody should know, pi r squared h. And so we just have to find these two things and then add them together. Okay, so we're told that the radius of the cone or cylinder is 12. And the slant height is 15. Can't see that 12 very well, can you? Let me go back and do that a little better. So let me get that 12 in there. 12, there we go, 12. That's my radius. Okay, and the slant, he calls it in the problem, he calls it the slant. This is called the slant height. And the height of the cylinder is 56. So we know that this is 56 here. Obviously, the radius of the base here would also be 12. Put a big 12 there. And now it's just a matter of plugging in. We first need the height of the cone, and that's just going to come from Pythagorean theorem. So you would do 12 squared plus h squared equals 15 squared. And that is just, I don't know what happened to my note on that. I thought I had that. Anyway, so 15 squared is 225 minus 144, so 81. So h squared is 81, and the height would be 9. And so now I'm just going to plug into the volume. Volume is 1/3 pi. Radius is 12. So it's 12 squared. And the height we just found is 9. And you put all of that into your calculator, and you're going to get the volume of the pyramid. The pyramid on top is going to be 432 pi. And then the volume here is just pi r squared, so it's pi r squared h. R squared would be 12 squared. And the height here is 56. And so this comes out to be 8 0.0064 pi. And if you want the composite, the whole thing, 84, add them together, you get 84.96 pi. Now we don't know the units. We're not been given the units. Normally you would have units. This might be in feet, let's say, in which case this would be feet cubed. We're not being given any units, so we don't really know what to say about units. But I like this problem because it's very representative of a class of problems in geometry where you have two shapes or sometimes more than two shapes combined into a single shape, and you have to answer questions about volume and perhaps surface area and things like that. Also, I kind of like this problem because this is a shape that we can see in the real world. This would be, this might be a silo of some kind that's built, built above ground or partially below ground, and it would have this general shape. So these silos and shapes of this sort do occur in the real world. It's always nice to do something that's real world kind of problem when we're doing math. So that's it for this problem. Enjoy your trips, your travels through the world of geometry, and good luck with everything. Bye-bye.